Chapter 7 regarding deadlocks. Yeah, okay. All right. So this is the subtopic of the deadlocks system model, deadlock uh, characterization method for handling deadlocks, deadlock prevention, deadlock avoidance, deadlock detection, recovery from deadlock, and also summary. So I believe, okay, some of you have go through the chapter 6. So if at the end of that lecture, it is mentioned about the deadlock and also starvation. Yeah, starvation. So we need to see, yeah, how we want to avoid this deadlock. Okay, because of the incorrect, the value of SMART 4, incorrect implementation of SMART 4. See what happened. It will lead you to the deadlocks and also the starvation. All right. Okay. Next. So chapter objective to develop a description of deadlock which prevents set of concurrent processes from completing their task, and then to present a number of different methods for preventing or avoiding deadlocks, yeah, in a computer system. And system basically consists of resources, yeah, resources type like R1, R2, and so on, yeah. And then in resource type, we have like CPU cycle, memory space, I/O devices, yeah. So each resource type, which is Ri, has a Wi instances. For example, if a system has a 2 CPU, then the resource type CPU has 2 instances. Resource type printer may have 5 instances. Okay, please take note, yeah. Not one-to-one, so it can be more depends on the resource, yeah. So each process utilize a resource as follow. For example, first request and then use that, and after that you have to release. So this is the process to utilize a resource. Okay, first you need to request, after that use that, and then after that finally we need to release. Okay, all right. Resources can be a physical, for example, printer, disk drive, yeah, and many more. Okay, logical, for example, a record in database. Okay, that's a virtual, right? Smartphone, monitors. This is a logical. So this is they classify that resources can be in these two types. Yeah. Resources are partitioned into several types, which is R1, R2, and so on. Each consists of some number of identical instances. All right. So a process may utilize a resource in only the following order. First, as I told you, request, use, and also release. Okay, we need to give to another process to use these resources. So deadlock, many programs competing for limited resources. Yeah. So deadlock, which is a state when every process in the set of processes is waiting for an event that can be caused only by another process in the set. Okay. So for example, system has a 2 CD drive. Okay. CD1 and also CD2 drive. Yeah. So P1 and P2 each hold one CD drive, and each needs another one. Okay. All right. They are sharing actually. Yeah. So similar. So this is a deadlock situation. Okay, they give example of the car in the traffic jam. This is also the scenario representing of the deadlock. Yeah. Okay. So deadlock characterization. Deadlock can arise if four conditions hold simultaneously. Yeah. So for example, mutual exclusion. Okay, you already know that in the previous slide, previous chapter. Yeah. Hold and wait. A process holding at least one resource is waiting to acquire additional resources and held by other process. That's why I told you when you use, after that you have to release. Similar that this hold and wait pass. Otherwise, if you just create something, any algorithm, hold without wait, become problem. All right. So no preemption. So preemption is very important. Okay, so sometimes we don't apply preemption. We're not allowed to interrupt, for example. Yeah. So it will create this scenario. So resources can be released only voluntarily by the process holding it. After that process has completed its task. Yeah.